Hello everybody, glad to see you. Today we're going to talk about in a situation when we are going to have modifier for reference access or reference plane. As we can see here in this first example, on left hand side we are going to have this composite FCF for position control, and we are going to have TZ 0.5 and 1 with modifier MMC. At bottom we can see it is respect to A. At top we are going to have this TZ equal to 1 by having MMC respect to A and B, while we have modifier MMC for B, this reference axis. Where is A and B? A is located here, this plane, as we can see here. I'm going to show it by mouse, and B is this axis. Okay, now we are going to have composite positioning control. At bottom, we are going to take care about the orientation of the holes respect to each other. Mainly, let's say orientation. At top, we are going to have A and B. We know what is the meaning of this modifier here. It means we are going to have dynamic TZ. At top, we are going to have this, let's say, cylinder with the diameter of 1 respect to A and B. Now we have modifier for B. The best way to understand what does it mean is if we are going to make gauge. The topic is if we are going to make gauge, what should be the size of gauge? When we have this M, it means material condition. For this part of this component, the maximum material condition means we are going to have the maximum material on this part. It should be 51. We need to make a gauge while the hole has a diameter of 51. No matter what is the diameter of this component, it should be 51. However, the diameter of this part should be between 50 and 51, but I'm talking about the gauge. The gauge has a fixed hole diameter with 51 because we are going to have modifier maximum material condition here for B. It means for any other diameter for this part between 50 and 51, we have this possibility to move this component, to shift it. That's why always we are going to say this modifier for reference plane or axis is going to make more shift. And here at the bottom we are going to have A. It should be perpendicular to A with this TZ. That's why we are going to have another cylinder here. We can see at bottom right we are going to have this small cylinder with a diameter of 0.5, and the axis of the hole should be between these two cylinders. And here this small cylinder is going to take care about the relation between the small holes respect to each other, and the cylinder with the diameter of 1 is fixed there. However, we have this possibility to shift based on the diameter of this part of the component, because the whole diameter on gauge is 51. If the diameter of this part is, let's say, 50.8, we have this possibility to shift it and rotate it. It should be in this interval. Here we are going to have another example. We are going to have 3 sets of holes here, here, and here, and here. Let's talk about this one. What we can see here, we are going to have 2 independent FCF feature control frame. At bottom we are going to have a, let's say, TZ 0.25, and at top we are going to have TZ 0.8. A is located here, B is this plane, and C is this plane. We can see here on left hand side. Here at bottom we are going to have this small TZ, this cylinder with a diameter of 0.25, and the big cylinder has a diameter of 0.8. And we are going to have this A should be perpendicular to A, and respect to B we are going to have this basic dimension, and respect to B as well, it means it can go left and right, but it should be in that interval, in this big cylinder, as we can see here. Here, I would like to highlight, please see at the bottom, right? The axis of this cylinder should be in both TZs. As you can see, the axis of this cylinder should be, for the hole, should be in this cylinder and also in the big cylinder with a diameter of 0.8. And let's talk about this set of holes at top. As we can see here, we are going to have TZ 0.25, TZ 0.8 respect to A and B, A and B and C here we have, and we don't have any modifier for A and B and C. Let's see here. Yeah. Here, at the bottom, we are going to have this TZ 0.25 respect to A. A, we know where it is, perpendicular to that, and B, it means the distance from this surface should be constant because it is a reference plane here, and that's why it should move left and right, just this point. And these are small holes, these are small diameters. It's going to take care about respect to each other, and the axis of the hole should be in both of them, in both TZs, as it is highlighted here in this figure. We can see here at the bottom. I'm going to show it by mouse. Yeah, and here whenever we are going to have C, we need to have basic dimension here, and we can see here we are going to have basic dimension here. And whenever we are going to have positioning, for sure we are going to have basic dimension. As we can see here, and in previous example, we are going to have basic PCD here and basic angle between two holes, and the rest as well. Here we are going to have another example. We are going to have TZ 0.25 respect to A and B. We are going to have modifier M here, and we are going to have another independent FCF with a TZ of 0.8 respect to A, B, C. We are going to modifier for B and also C. What does it mean? It means for B is here. We can see this axis. We are going to have maximum material condition. For that, we need to have maximum diameter for this part. It should be 51. It means we are going to make a hole with a diameter of 51. And C, what does it mean? C is this width. And for this width, we need to have the maximum material condition. It means if we are going to make a gauge, we are going to make gauge with a small value for that based on the size TZ. We are going to have that. It means we have this possibility to shift the component in that gauge. In another way, we are going to increase somehow the TZs. But let's say shift. We have this possibility to shift the component through that gauge. We are going to have more freedom. Here, the same as always, we are going to have, let's say M we are going to have here. It means we are going to have dynamic TZ. We discussed about that a lot. And here, we are going to have two cylinders, the diameter of 0.25 and 0.8. And at the bottom, we are going to take care about A and B. It should be perpendicular to A and B. Whenever we are going to have maximum material for B, the gauge should have a hole with a diameter of 51, and we have this possibility to shift it, to shift and rotate this component in that situation. In a way, these two cylinders should be in a way, the axis of this hole should be in both of them. Let's see this example here. We are going to have here, we are going to have two independent FCF, and we are going to have modifier for B and C as well. B is this axis, and B is here for this, and C is here exactly for the axis of this one. This is a slot here, and A is this plane. For sure, we know we should qualify A and B and also C somehow, And now we would like to discuss about this modifier for B and C. Whenever we are going to make a gauge, we need to have a maximum material condition for B. It means we need to have a, let's say, maximum material here. The gauge should be the smallest value of that. It should be 17.6. And also for C, we need to have maximum material condition, maximum material here. It means that gauge should have the smallest value. It should be 3.4. It means we have this possibility to shift and move this component through that gauge. And now here we are going to see what's going on here. A is this plane, as we can see here. This plane is shown here at bottom. And B is this axis we can see here. And C is this plane here. It is based on maximum material condition for B and C. And we are going to have two cylinders with a diameter of 0.25 and 0.8 that is shown here. And the axis of the hole should be in both of them as it is highlighted here. And at bottom, yeah, we are going to have these two independent FCF. I should take care about B as well, not just orientation. Also, location with respect to B is important here because these two FCF are independent. It is not composite positioning control. It is two independent FCF. Yeah, here we are going to have another example. We are going to have this component. Here we have A, reference plane A, and B is this axis. We are going to have 0 MMC condition for that, and we call it this axis as B. And for this hole, we are going to have this 0 MMC respect to A and B. We have modifier M for reference axis B. It means we are going to have the maximum material here. We need to have a smallest diameter of pin for gauge here. We are going to have this gauge here. It is highlighted here. What does it mean? It means for this we are going to make a gauge with this diameter. For this hole it is 0.2, and it is for A it is 0.8 here, as it is, sorry, 8 here, 9 minus 1. And whenever we are going to use this gauge here, we can see for this MMC condition there is no possibility to move the component. It should be in that TZ. But while the diameter of these holes are different, let's say this hole at the center, it can be between, let's say, 12 and 14. Let's say it is 14, but the pin diameter is 12. And also for another hole here, we can see, let me see what is diameter of that. It can be between, let's say, 8 and 10. Let's say it is 10, but we are going to have a pin diameter 8. It means we have this possibility to shift and move this component through that gauge. Here we have just one hole here. Somehow it is going to make, let's say, bonus for that. We can add this TZ to that TZ as well. But whenever we are going to have two holes, it doesn't work like that. But the concept is exactly the same. Here we are going to have two holes here, and again the same situation happened. We are going to have A here, B is this axis, 0 MMC respect to A. We are going to have 0 MMC respect to A and B. We have modifier B here, and here we can see the diameter of this pin for gauge should be 12 because we are going to have MMC here, and let's say we are going to have diameter of the 8 for these two pins here. For MMC situation, we don't have this possibility to shift or move this component through this gauge, but for other diameter, easily we can see we can have this shift and movement, but it doesn't mean we are going to add to the TZ. That's why always I say, let's say whenever we are going to have modifier for reference plane or reference axis, we have the possibility to shift and move the component through the gauge, not adding any 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 other number to mention TZ. Yeah. Now I would like to close this session regarding having modifier for reference plane or reference axis. In coming session, I'm going to talk about the shaft. I hope you enjoyed. See you next time. Have a nice day.